Good morning once again. So here we are again. And in our previous class, we tried to introduce software design patterns, of which we learned about some common patterns in software. And I also encouraged you to extend your research so you can get used to these patterns. And if in case you find yourself anywhere, any company, you'll be able to adapt. So nothing will be new to you. Yes, so today, I know some of you have been waiting for this. We've not built any server-side application. What's the problem? This is that, this is this. We are supposed to talk about testing, integration testing, end-to-end testing, and all of that. But I decided to announce this is our final, let me say our final module, because everything will be about Nest.js, all the ORMs, testing, and everything we'll be discussing will be under will be within this module. That is building server-side application with Nest.js and every other thing. So some of us don't know what ORMs are, ODMs. We'll come to that. And then testing, we'll introduce testing, we'll talk about unit testing, integration testing, end-to-end testing, and all of that. But so today, we will be introducing Nest.js, the framework we'll be using to build our server-side applications. So some of us knows what we already know what Nest.js is, but some of us still doesn't know what Nest.js is. So we have a couple of frameworks. We have Express.js, we have Fastify, we have NodeJs. And to be honest with you, Express.js is the oga patapata of them all. So even Nest.js relies on either Express.js or Fastify, I guess, but we'll see that why we progress. And we also have Honor.js. So before we even introduced Nest.js, and let's take a look at let's see, Express. Mention the Express.js. So if you take a look at Express.js here, fast, unopinionated, minimalist web framework for Node.js. So all of these things, you go to getting started. Some of us have used this, and I believe, and we've learned this from tutorials and all of that. We've learned about middlewares and all of those things. We even have a guide here that will guide you and all of that. But believe me, you still don't have an idea of how powerful this framework is. So this is Express.js. I've been using it. I use it to learn back-end development back in the day. But right now, I can build with Express.js, Honor.js, and Nest.js. But I won't tell you which is my favorite. Just concentrate. So we have Fastify. I've not really taken my time to actually explore Fastify. And this is my first time of even visiting their homepage because I've had no interest in even trying to look at it. But here is this. Here it is: fast and low overhead web framework for Node.js. So the reason why I prefer Express.js and Honor.js is I want to be in control. I want to be in control. I want to be able to know what is going on under the hood and what I am doing. So frameworks like Fastify and Nest.js, they have a whole lot of overhead and a whole lot of abstractions, not overhead actually, a whole lot of abstractions that I, in person, I don't really like. But at the same time, they simplify all these complex stuffs that you'll be doing while using Honor.js or Express.js. Okay, so Fastify, then we have Uno.js. Sorry to say, but this is um my go-to backend framework. Express is the boss, and I love Express, but Honor is my go-to. Honor web application framework, fast, lightweight, built on web standards, supports for any JavaScript runtime. So we have the docs here. The docs, we have the concepts, web standard, motivation routers, middleware, and the rest. And we have this for NPM, for Yarn, for PNPM, for Bone, and for Deno. It supports all runtimes, Bone, Deno, Yarn, NPM, and all of that. Getting started, we have Cloudflare workers, we have Deno, we have Netlify, and we have Node.js. So I only use Node.js. So this is this one here and all of that. So you can take a look at all these things. And the one where we'll be using is Nest.js. So here's Nest.js, a progressive Node.js framework for building efficient, reliable, and scalable server-side applications. Indeed, it is what it says it is, because you can actually use it to build progressive, um, sorry, to build efficient, reliable, and scalable web server-side applications. So you can build this, you can build any application with Nest.js without even have to think about any architecture also. But when it comes to Express.js and Honor.js, you have to decide the architecture you want to actually use. But with Nest.js, the architecture is already in place for you. Just follow it and your code will be well structured out of the box. And we'll see that in a bit. And for today, we'll just be introducing Nest.js with its core concepts. I guess in our next class, we will start building something, or if not in our, let's say, next week, not in our next class, but probably next week, we start building with Nest.js. Because we first of all have to understand what ORMs and ODMs are. And we will also learn about testing. So when we build any application with Nest.js, we will properly test it and make it production ready. Good. Okay, so now let's go back to the business of the day. Okay, so introduction to Nest.js. Wow, we have a whole lot of things on our table. The first item is introduction. We have overview, controllers, providers, modules, middleware, exception filters, pipes, guards, interceptors, and custom decorators. What are all these things, and why do we have a whole lot of things in Nest.js? And these are some of the things that makes Nest.js what should I say, as good as it is. Yeah. So when we move over to introduction, we have what is Nest.js. We look at the philosophy and we'll look at how we can install Nest.js. So essentially, we'll be moving back and forth. So first of all, let's assume I don't know what Nest.js is. So we are learning it together, right? I don't know what Nest.js is and what it can do. So we are learning it together now. So let's learn together. So if I make any mistake, you correct me, because we'll be going through this documentation together so we can learn Nest.js together. Okay, so what is Nest.js? According to the documentation, we have Nest.js. Okay, let me zoom in a bit. Okay, so I guess this is okay. This is bold enough. So Nest.js, Nest, known as Nest.js, is a framework for building efficient, scalable Node.js server-side applications. So it uses progressive JavaScript. It's built with and fully supports TypeScript, yet still enables developers to code in pure JavaScript, and combines elements of OOP, object-oriented programming, functional programming, and FRP, functional reactive programming. So under the hood, Nest makes use of robust HTTP server frameworks like Express. So this boils down to why I said it relies on either Express or Fastify. Remember, I don't know Nest.js. Maybe I guessed something like that. So under the hood, Nest makes use of robust HTTP server frameworks like Express, which is a default, and optionally can be configured to use Fastify as well. And this is awesome. And this really doesn't mean you have to know how to write server-side applications in Express.js before you can use Nest.js. No. Remember, it is stated here that it is the default. So everything is configured. So you just have to pick up Nest.js, build whatsoever you want to build with it, and you are good to go. So Nest provides a level of abstraction above these common Node.js frameworks like Express/Fastify. Remember what I said, I love Express on Honor because of too many abstractions in Nest.js. But also exposes their APIs directly to the developer. Yes, and we see that when we start building with Nest.js. So this gives developers the freedom to use the myriad of third-party modules which are available for the underlying platform. So it gives you the freedom to use the Express.js APIs or Fastify. So if you've been building with Fastify or you've been building with Express.js, it's a very simple thing. You can opt into Nest.js and you still have Fastify or Express.js handy. You're good to go. Okay, so the next on our list is the philosophy behind Nest.js and how we can install it. Okay, so now we have, so in recent years, thanks to Node.js, JavaScript has become the lingua franca of the web for both front-end and back-end applications. This has given rise to awesome projects like Angular, React, and Vue, which improve developer productivity and enable the creation of fast, testable, and extensible front-end applications. However, while plenty of superb libraries like helpers and tools exist for Node.js and server-side JavaScript, none of them efficiently solve the main problem of architecture. And when I mentioned earlier, but I said Nest.js gives you out of the box the architecture you need to build any form of server-side application in any kind of complexity at all. So Nest provides an out-of-the-box application architecture which allows developers and teams to create highly testable, scalable, loosely coupled, and easily maintainable applications. So the architecture is heavily inspired by Angular. And when we were talking about dependency injection, remember I mentioned that Angular, it's built on top of dependency injection. When we were talking about design patterns, we actually did not touch that part. But then before that, we learned about dependency injection. I told you that Nest.js heavily relies on dependency injection. So moving on, the next on our list is installation. So how do we get started? You can either scaffold the project with the Nest CLI or clone a starter project. Both will produce the same outcome. So to scaffold a project with the Nest CLI, we run the following command. So npm I. So we install globally the Nest.js CLI so that it will be, I think, since I guess we should just use this to learn Nest.js. We should just use this starter since I'm a beginner as well. So let's see what this starter looks like. Okay, still here. TypeScript starter project. Okay, so we are not cloning. But first of all, we are learning together. So we need to install Nest.js globally. So if I come over here, and I say, what is the command again? npm ig at, okay, let's just copy this. So they even have a CLI, a handy tool that you can use to create and manage projects. So if I come over here, ls cd desktop project, okay. So I am in my project directory. So, but first of all, I will need to install Nest.js globally. But if I do this on the Mac, I'll get an error because it need an admin permission to install globally on Mac. So if I hit enter, it will try to install, but then try an error. So let's see what we've got. Maybe it will install, maybe not. So I guess my network is as well slow. Okay, so wow, I never knew it is slow. So here we can see we can create new in the next new. Once we have the CLI installed, we can create a new project using the next new project and then the project name. So to create a new TypeScript project with strict self feature set, we pass dash strict flag to the next new command. Okay. So we'll do that actually. Alternatively, to install the TypeScript starter project with Git, you can just clone it, install and start. But we want to be able to do these things by ourselves. So let's see if this has thrown an error. We have an error here. And this is simply because access permission denied, blah 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 access. So it's because of the. So if I come over here and say sudo, that is admin permission, and paste this. Nope. Nope. I hit enter. It will ask for my password, and I will quickly enter it. Hit enter, and now after delay, this will be okay. So if you want to see it in JavaScript, you just click here and it will toggle to JavaScript. This is JavaScript main.js, and if you click this, it will toggle to TypeScript main.js. Okay, so we've seen this, but we don't know what controllers are. So going over this and then trying to look at Nest Factory, no. We first of all need to understand what controllers are. Then we'll understand why we have the project created with those controllers. Now, if you come over here, okay, packages installation. In case you don't see any errors above, consider manually running the feed command npm install. Okay, so let's clear the terminal. And what's the name again? KC Nest. Okay. C code KC Nest. We want to open it in VS Code. So if I hit enter, VS Code will open with so let's go ahead and close the one we've opened before. And now we have our Nest.js project, but we've not installed because as you can see, there's no node modules folder here. So I'll quickly open the terminal and run npm i. I'll hit enter. So we want to install this. So while it's installing, we have the tiers, the normal tiers config here. And because it is strict, the target is 2023, the source map is true, the out directory is dist. So all the things we've learned, if you run npm run, if you look at the package JSON, let's start with the package JSON. We have the name of our project is Nest. The version is 0.01. The description is empty. Author is empty. And the license is on license. So the build here, Nest build, we build our project. We want to format, we run npm run format, and prettier here, we format our projects with these rules. If you want to start our project in production, write npm run start, and Nest will start our project for us. If you want to run it in development, npm run start dev, and it will start in watch mode. Start debug to start in debug mode. Okay, so actually this one is, let's start is just to start in dev, but start dev is to start in watch mode. This one is not in watch mode. Then start prod is to start application in production. Node dist main. If you want to link your project, if you want to test, npm run tests. So they are using in Nest.js, they use jest and not vtest or any other. So if you want to watch your test, test watch. If you want to see the coverage for the test, test coverage and every other thing. So test debug. If you want to inspect, test end to end. There's an E to E config test E to E JSON here that you can configure your end-to-end test. So we have dependencies. We have the Nest.js common, Nest core. Then we have Nest.js platform express, which is the default on the lane platform for Nest.js. So we have the reflect metadata and RxJS, which what they are using, all these things they use under the hood for the architecture and dependency injection and the rest. We also have development dependencies. These are the dependencies we use for development. TSJS, TS loader, TS node, TS config, TypeScript, and the rest. Okay, so we still have this error. And what is the error saying? Okay. Invalid response, but invalid response body. While trying to fetch this registry, permission denied. Okay, file exists, this npm catch. Okay, so let's try npm I dash false. So npm one using that as false, recommended productions will be disabled. Okay. Oh wow. Missions denied. It exists. What exists here? This is the same. Okay. By response body, we're trying to fetch this registering periods, just result dependency. Rename condition by to this file exists. This. Remove the existing file and try again around npm. I first override files recklessly. Okay, so I don't know why we are having that issue. So I guess we should just debug. Nope, not cursor. I guess Up to this point should be okay. So let's see if Google will be able to help us. Remember, we don't know what's going on. We're all beginners, and so what is it saying? Here's a breakdown. NPL code exists here. System call. Corrupt npm cache, file permissions. Oh, okay. So now we need to clean the npm cache, and then we'll verify the cache as well. Okay. So let's copy this command quickly. Paste it here. Then hit enter. Let's see if the cache will clean. I am right now cleaning the npm cache on my machine, and here is another error. Okay, to permanently fix this problem, we run this command, and then grant the permission with my password. Change ownership. We're changing ownership here. This has to do with bash and all of that. So you don't need to explain. I'm changing ownership. So now if I run npmi, let's see if this doesn't work, we'll clean the cache again since we've changed ownership. And then we'll try to run it again and see what we got. So while it's loading, it's taking time. Okay, so I guess this is a sign that it will work now. So we're trying to look at package.json and to see a few commands in the package.json file, which we saw, and we also have super test. So super test is actually for testing. This is super test, testing APIs, I guess. Super test, super agent reliable for testing HTTP servers and all of that. So you can go ahead, look at super test and everything that it has to offer. Okay, so moving on, we have controllers. So moving on, we have controllers. So what does Nest.js team have to say about controllers? So here, there's just a simple explanation here. Controllers are responsible for handling incoming requests and sending responses back to the client. So we have client side, you send an HTTP request, then we have a controller, and controller. So if you send, is it the user? We have the user controller. Is it authentication? We have authentication controller. Is it any other controller? We have it here to handle it appropriately. So here we have a controller's purpose is to handle specific requests for the application. The routing mechanism determines which controller will handle each request. Often a controller has multiple routes and each route can perform a different action. So to create a basic controller, we use classes and decorators. Decorators link classes with the necessary metadata, allowing Nest to create a routing map that connects requests to their corresponding controllers. Wow. So basically, the technical details for, I guess we should just come back, share. We'll have controllers. We'll first of all look at the technical details. So the technical details we have the decorator, we have route handlers, and we have dependency injection. We also have request/response object. Okay, so the decorator, which is at controller, marks class as a controller. Then the route handlers, we have method decorated with HTTP verb decorators like at get, at post, at put, at delete, etc. So dependency injection, controllers can inject providers through constructor parameters. So we mentioned also request/response object, access to express request response object via decorators. So here we have routing. So in the following example, we will use a controller at controller decorator, which is required to define a basic controller. So we specify an optional route path of cat using a path prefix in the controller. So decorator help us group related routes together and reduces repetitive code. For example, if you want to group routes that manage interactions with a cat entity under the /cat path, we can specify the cat path prefix in the controller decorator. So this way, we don't need to repeat that portion of the path for each route in the file. So here we have cat.controller.ts, and we have at controller cat. Then we export class cat controller, and this one here is a get method. So we say, okay, return this action returns all cat. Okay, so let's see if we're done installing. Okay, so now we've installed and we can see node modules. So let me clear my terminal. Okay, so now let's see, if you open our packages in, we see a couple of scripts here. Which one of them is start dev? So say npm run start dev. Now, if I hit enter, you'll be able to start application. It's starting compilation in watch mode. Then we have our dist, our distributable folder here. Everything is inside. Starting Nest application, app module dependencies, map gets, and every other thing. So it's running on port 3000, even if you can't, if you open the source folder and we come to the main TS, you see app listen process env port or 3000. So the port here is undefined. So it's running on port 3000. So if you come over here, we open localhost, say 3000, have hello world. If you come to our terminal, we'll see, okay, we are seeing this error. Promise must be awaited and with the call that cache. So this is not necessary since there'll be no errors here, but we can basically say .catch. I can do something like this, and we can leave it like this in order to do away with the error. Okay, so if we come back to our app service at injectable, so all these ones, we'll talk about these ones later. We have app module. At module here, we have controllers, we have providers, we have imports. So there are no imports. We also have, you can even specify exports. So these are services in this module that can be used outside of the module. So for now, let's leave it like that. We have imports, controllers, providers. So if you come look at the controller here, we have at controller. So export class app controller private. This is a constructor, private, and it's read-only app service. So we have a get method which returns gets hello. This app service dot gets hello. App service is coming from app.service. So if you open app.service, we have hello world. If you say hello world, man, and you save. Now, if we open our browser, we see, okay, so guess we have hello world, man, here. Okay. So we also have our test. So we are testing, should return hello world. Now, if you run our test, it will fail because we changed it to hello world, man. Let's change it back to hello world like this, and we're good to go. So essentially, we have the module, controllers, controller specs, yes. So this is where we're testing. App controller, blah, blah, blah. Create testing module. So this is the basic, this is the boiler plate for our app. If you want to configure end-to-end test, we come here, we have transform, test rejects, E2E spec, root directory, JS, JSON, TS. Test environment is Node because we are testing server-side application. So app E2E spec tests. So they also left an example of an end-to-end test here for us. Okay, so we have an error here. Return of value type error. On self return of value. So what's happening here? Okay, expect 200. Oh. I know. Let's leave it there. Let's leave that for now. But this is just the basic architecture of our app. So this is a service, which let's say, for instance, we're getting something from a database. We're getting this from a database. So we mark it here as injectable. Now, if I hover this injectable, now this is a decorator. So decorator that marks a class as a provider. So providers can be injected into other classes via constructor parameters, injecting using Nest built-in dependency injection system. So now if I go ahead and comment this and save, now it's possible we have errors because if you come over here, we're injecting this service here. So maybe I should just go ahead and refresh. So we'll see if we have errors or not. Okay, we have hello world and there are no errors. Okay, so this is marked as injectable, but when we comment it, we still have no errors. Okay, so we have app module. We have providers here, which is app service that we can use. Now, if I go ahead and comment this out, there are no provider, and then we have an error. But for now, this is just the basic boilerplate for our app. Let's go ahead and look at this. So to create a controller using the CLI, simply execute Nest.js controller and then the controller name. So the @get decorator here is HTTP request method decorator placed before the find all method. This tells Nest to create a handler for a specific endpoint for HTTP requests. So this endpoint is defined by the HTTP request method get in this case. And the route path. So what is the route path? So the route path for handler is determined by combining the optional prefix declared for the controller with any path specified in the method decorator. So since we have set a prefix cat for every route and haven't added any specific blah, 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 if we have dash cat request to do this. So what this is trying to say is, let's come back to our application. So in here, we have a service, we have the controller, and let's stop our server, clear the terminal. Okay, so let's go back to, so we'll run this command to create a controller. So this is for cats. Let's say we want to create let's create a controller by executing Nest.js controller, and then okay, so let's create the cat controller as mentioned here. Let's do something like this. Or I can even show you an example using the existing one. So if you come over here, if you do this, and you see, this one should be app. Now, if you save this, we start our server, npm run start dev. Okay, so if I come over here and refresh, so cannot get this, not found. Status code is 404. Because what do we have in our controller? We have app. And even on the CLI, we're saying mapped to /app. Now, if I come over here and do something like this, /app, now we have hello world. So this decorator here is simply telling us, well, if you do something like, okay, /app/ something else, okay, that will map to that. Okay. Now, if you have this here, if you hover over this get, now get also takes an argument of path, which is optional. It can be an array of strings. So route handler decorator, which routes HTTP GET request to the specified path. So if I say that is app, then let me say test, and I save. Now, as we can see, the app controller /app, but this is a route explorer. This is mapped to /app/test. Now, if we come over to our browser and we refresh, it will not be found. We say /test. And now we can see hello world. So with Nest.js, all these things are very, very simple. So this is all they are trying to explain here. Nothing much. So you can even explore other things like at response, at next, which are middleware, pass through, and every other thing. So while looking at everything and looking at routing and everything, do not also forget what controllers actually are. They are responsible for handling incoming requests and sending responses back to the client. Okay, so let's create, let's come over here and see, stop our server and run Nest.js controller and say cats. Is it cats? So we can be in sync with what they are trying to do. Cat, yes, it's actually cats. And if we hit enter, the CLI will create a cat folder. And in here we have cat controller. And you can see the class is empty. So if you come over to the app controller and then let's just remove this and remove this. Now, if you save our file, say npm run app start dev. Now see what the command did. It created a folder of cats, and we have cats controller spec with some text inside and cats controller TS. This is an empty cat class, and the controller here will automatically have cats inside. Have app controller spec TS. So this one is for our app. In the cat, we just have the cat controller and cat controller spec TS. Now, if you come over back to our browser and we try to refresh our page, cannot get /app/tests. So we removed that. We can do this. And if you try to do something like /cats, and now cannot get cats because the class is empty. Now, if you come over here, so this is what they're doing in the cats. You can just come over here, grab this, define, or let's assume it's a database query. Bring it over to our cat controller, then we paste it in here. And the get here, let's import it from Nest common. Great. So as you can see, map to /cats. But if you try to refresh, this action returns all cats. And now we have it here because we've implemented this controller, and now it can respond to HTTP requests. This action returns all cats. This is a get method. So if you change this to put, and you save, now if I come over here and refresh, cannot get cats, because now you are telling Nest by simply changing this to put that this is a put request and no longer a get request. Can you see how simple Nest is? Now if I can come over here and remove this. So we're now good to go. Now I can refresh. Okay, nope. I can refresh the browser and we're back to where we were. Great. So now that we've created the cat controller and we've seen how routing simply works, we'll move on to providers. We know what a controller is, handles requests and send back responses to client. But what are providers? So we looked at the technical details, the key features. The key features are just what we've seen, the route parameters at param, that the decorator extract route parameters. And then we have the query parameters, we have the request body, we have at headers, we have a route prefix. So what this is saying is it's just simple. This is the route prefix. This cat here is the route prefix. And then as we have the at get here, we can have something like at headers like this, at headers. This can come from Nest.js common. We have at headers, we can have this, and then we can have at query. We have at query as well, and also at params. We can see how we use this in just a bit, but for now, all this exists in Nest.js common package, so we can just import it from there and use them with less stress. Come over here, clean this up. At get. So this is a get request. So this must be here to specify, okay, this one is a get request. Great. Now that we've seen we've seen the key features, the internal mechanism is it's very simple. We've already demonstrated this. So controllers are registered in modules, and Nest.js automatically creates route mapping, like route mappings based on decorators. So the framework uses reflection metadata, the package you saw there, and parameter extraction requirements. So everything is handled under the hood for you. All you need to do is just follow instructions, learn it very well, you're good. So we have providers. So what do Nest.js have to say about providers? So providers are a core concept in Nest. Many of the basic Nest classes, such as services, repositories, factories, and helpers, can be treated as providers. So the key idea behind a provider is that it can be injected as a dependency, allowing objects to form a various relationship with each other. So the responsibility of writing up this object is largely handled by Nest runtime system. You don't even have to worry about factories, DI factories, like dependency injection factories and the rest. Nest.js handles this under the hood for you, but they're just trying to let you understand how these things work under the hood. So we have the value component, we have factory, we have component, and then we have a controller here. So in the previous chapter, we created a simple CAT controller. Controllers should handle HTTP requests and delegate more complex tasks to providers. So providers are plain JavaScript classes declared as are providers in the Nest.js module. So for more details, it refers to the modules chapter. Okay, but for now, we're just looking at providers. So providers also have services. We have services here. So let's begin by creating a simple CAT service. So this service will handle data storage and retrieval, and it will be used by the CAT controller because of its role in managing the application's logic. It's an ideal candidate to be defined as a provider. Now, how do we create the CAT service? To create a service using the CLI, simply execute the Nest.js service CAT. So first of all, we'll create a service. Let me quickly stop the server here, clear the terminal, and then also I'll run nest-g service cat. And look at what will happen. If I hit enter, and now we have in this cat folder, it's not outside, it's already know that, okay, we have a controller in the cat folder, so we need a service. Now in here, we have, it's injectable, that we can inject it in the controller, but then as you can see, it is mentioned here. It is mentioned here that the service will handle data storage and retrieval, and it will be used by the CAT controller. Now look at this. We'll just come over here. Let's grab this. So there's also a CAT interface. And okay, so we've not gotten to this is just a TypeScript stuff. So additionally, this example makes use of a CAT interface, which likely looks something like this. So if you come over to the CAT, look at how the architecture is going so far. In the CAT, we have the CAT service, the controllers, and everything. It's just a specific module for CAT. Now, if you come over here, we'll create a folder, and then we call this interfaces. So what is the name here again? The name here is interface CAT, which is CAT interface TS. If I copy this, come over here, create a file in these interfaces, and then call it cat.interface.ts. Then you paste it. Now we are good. The name of the cat, the age, and the breed. Now this is the use of knowing TypeScript. We don't even need to wonder, oh, what is an interface and what do we even need it? So now that we have the cat service, we can now come over here and copy everything inside of this cat service, then bring it in here. Hit enter and paste. So now let's save it. This is private. So this cat array is private and it is read only. You cannot modify the array. Actually, you can modify the array, but it is read only here means you cannot modify it at runtime. And we have private here, means you cannot access this array outside of this class. And now we have the cats here. So we'll see import cat from cat is from interfaces from nope, just the / interfaces and cat interface. And now TypeScript is happy. So now this is a service. Now we can create a cat. We can find all. Now the cat array is empty. So this, if you want to create a cat, you provide a cat that matches this interface. So if you want to create a cat, You first of all provide the cat with a name, age, and breed. Then you can be able to create a cat that is to push the cat to the array. Now, if you want to retrieve cats, you say find all, which is a method that returns an array of cats. Now, TypeScript will start making sense to you. And if you never paid attention, I'm sorry for you. You become frustrated. Okay. So now we have the cat service. So we've created a cat service. So our cat service is a basic class with one property and two methods. The key addition here is the injectable, the injectable decorator. So this decorator attaches metadata to the class, signaling that cat service is a class that can be managed by the Nest IOC container. Okay, let's open this up. In software engineering, inversion of control is a design principle in which custom written portions of a computer program receive the flow of control from an external source. Let's not go beyond that. You can check that out. Okay, inversion of control container. Nest use that under the hood. So we don't even need to know anything about it. We just need to know that service controllers uses services. So now we have the interface, we have the controller. So now that we have a service class to retrieve cats, let's use it inside the cats controller. So we also need a DTO. Now, if you come over here, so where is the DTO? Okay, so since there's no DTO, we have to create that by ourselves, and then we'll look at what DTOs are. So if you come over here in the interface, we have another folder in the cards, and then we'll call this one DTO. And here we'll create a file, create cat.dto.ts. And then we say export create cat DTO. So this is a class. Okay, so say what is a DTO? And then Copilot has given us an answer here. It's a data transfer object. It's an object that carries data between processes. When you are working with APIs, you often need to send data from the client to the server or vice versa. So a DTO is used to encapsulate this data and send it over the network. It helps in defining the structure of the data being sent, ensuring that both the client and server agree on the format of the data. In Nest.js, DTOs are often used to validate and transform incoming data before it reaches the business logic layer. They can be used with the validation libraries like class validator to enforce rules on the data structure, such as required fields, types, and formats. This ensures that the data is in the expected format before processing it further. In summary, a DTO is a simple object that defines the shape of data being transferred, helping to ensure that both the client and the server understand the data structure and can communicate effectively. I think we should stop here. Thank you, Copilot. And I will leave it here. And later, if I push, you can look at what a DTO is. So now that we have create cat DTO, let's come back to Nest.js. And now in the cat controller, we have the cat DTO, the cat service, and the cat from the interface. Now we have this decorator here, post. Now this method are now asynchronous methods. So let's come over here, copy this, come to the cat controller. Nope. Oh. Cat controller and paste it in here. So we have to import this from Nest common, import at body from Nest common, and then import DTO from DTO/create cat DTO. This cat service. And so we need to also import cat service from cat.service. So now we create private read-only cat service, which is this cat service we're injecting in here. Okay, so Copilot, do not do more than you're supposed to. So we have a constructor, private cat service. Okay, so we're injecting it, but then in the constructor, not elsewhere. So let's remove this. And here we have a private cat service and this. So if I go ahead and save, we have our post method. And okay, so what is this saying? The method create has no await expression. So we say await. Nope. Okay, not here. Okay. So I guess we don't even need await, but since the create may be an asynchronous method on the service, the cat service, we just leave the async. Okay, so let's talk about what's going on here. Let's hover over this. Over this quick fix this line. Let's disable this rule. So at post, so we are telling Nest.js this is a post request that we want to create a cat, and then we provide the body of the data we want to create. Create cat DTO. That is the body. Remember what a DTO is. You can always refer to this, what Copilot has given us. So we have a create cat DTO, which is the body we want to create. And we have create cat DTO here. And then we have this cat service.create cat DTO. Always remember how dependency injection works. We have injected the cat service in the cat controller. So we have access to the create. Remember how we are creating a cat. And now we're passing the cat to this cat here, and then we're adding it to the array. So in the controller here, we're just calling the cat service and then invoking the create method, therefore passing this create cat DTO. And then look at what happened. If I come over here and comment this, we get an error. And it will tell you that no, argument of type create cat DTO is not assignable to parameter of type cat. Property age is missing in type create cat DTO, but required in type cat. Can you see that? Great. Now if you come over here, uncomment this, and we are good to go. Now, if you look at our create method in the controller here, we are simply creating a cat. And this is a post request because we are, you know how post requests work. We send data. We are sending a request with data that can be created. We're not making a request to get data. We are actually posting data. We're sending data that can be added to our storage or database or something like that. Great. And now in the cat service, we already have the create method that handles the logic. There's the logic of adding it to the database, handling errors, and doing the rest of the work. So we're good to go then. Now, coming back to Nest.js, we have another method here, which is the get method. And this one is an asynchronous method. It's a promise, and it resolves to an array of cat. So let's copy this quickly, bring it to the cat controller, and then replace this with this one here. So let's import cat. Okay. Okay, so we can just say return await. And this is also because await of a non-promise, non-tunable value. Okay, this is not asynchronous. So because we're making this async for now, because normally database operations are asynchronous, but we can go over here and say, okay, disable this rule for this line as well. So async find or promise, it resolves to an array of cats. Great. So now we've seen how a service and controller can work. Now we have the cat service that creates cats and find cats. So return this dot cat. Okay. So this is the reason why I've been saying you should focus on the basics. So things are beginning to get messy here. Not really messy, but about if you don't understand what's happening here, you get confused because this is a combination of dependency injection, JavaScript classes, TypeScript, and other things. So I believe we are confused about something. I know very well that most of you here will have a question in mind. What is a decorator? And why am I calling this decorator? JavaScript decorators. Okay. JavaScript decorators. Okay. Um, I don't want us to read too much grammar. I just want us to just need a simple example. Okay. What are decorators in JavaScript? A decorator is a function that adds some superpower to an existing method. It allows for the modification of an object's behavior without changing its original code, but extending its functionality. Great. Now, we see a simple decorator. We have a function log. Then we have the target, we have a key, we have the descriptor. And I will say console.log, login key function. And then return descriptor. Great. Now, we have a class of an example here. We have at log, greet, console.log, hello world. Because example is equal to new example. Then we say example.greet, logs, login greet function, and hello world. Okay, let me just copy this. So the code above demonstrates how a decorator may modify the behavior of a class method by logging a message before the method's execution. So let's copy this. And we also have the decorator composition, but that's not what we are after. I want us to know the meaning of a decorator. And now, if I create a file, index.js, and I paste this in here, and I go ahead and say, okay, node index.js. Okay, so invalid expected token. This all. What's happening here? Okay, so we're running this in a TypeScript project. Copy this, delete this. Let's open KodeCamp 5. So we can have a freedom of running this. So let's create a file and call it index.js. So what's happening? Okay. Let's paste this. Let's run node index.js. Okay, so we're having this error here at log, invalid or unexpected token. Okay, log at log. So what is it saying now? Oh, this. Oops. Okay. So I just wanted to demonstrate the simple. I don't want to write anything from the beginning. But with what we have here, let me just zoom in and try to explain this without running the code. So we have the target, we have the key, and we have the descriptor. So login key function, and we have login greet function. Now, the name of this method is greet. Now, at log here modifies this. Now, if you call this method, it will first of all login greet function, and before it will log hello world. The greet itself logs hello world, but this decorator here makes it to login greet because it's referencing this method here, login greet function, before this can log hello world. So this is basically decorators. You can go ahead and try to understand what decorators are in JavaScript, but they are very powerful, and that's why we are using, that's why Nest.js uses them. So they are mostly used by library authors and frameworks as well. So you may get to understand, maybe if you want to understand what decorators are, you can, but then this is simply how they are used. So the cat service is injected through the class constructor. Notice the use of private keyword. This shorthand allows us to both declare and initialize the cat service member in the same line. That is streamlining the process. So dependency injection. Nest is built around a powerful design pattern known as dependency injection. We highly recommend reading a great article about this concept in the official Angular documentation. So if you pop this open, if you come over to Angular documentation, you look at DI. But I guess DI shouldn't be a new thing to us because we even try to build a DI container and all of those stuff. So if you come over to the Angular documentation, you read about DI, dependency injection, learn about Angular dependency injection, understanding dependency injection, creating and injecting service. You can come over here and learn about the DI as well. So in Nest, thanks to TypeScript and capabilities, managing dependencies is straightforward because they are resolved based on their type. So in the example below, Nest will resolve the cat service by creating and returning an instance of cat service. Or in the case of a singleton, returning the existing instance if it has already been requested elsewhere. Wow. So this dependency is then injected into your controller's constructor or assigned to the specified property. You have constructor private. So we've created an instance of this cat service, but if it's a singleton and the instance already been requested and created elsewhere, we just return the instance. But in this case, it's not a singleton, so we create the instance of this cat service here. We have scopes. Providers typically have lifetime scope that aligns with the application lifecycle. When the application is bootstrapped, each dependency must be resolved, meaning every provider gets instantiated. Similarly, when the application shuts down, all providers are destroyed. However, it's all possible to make provider requests scoped, meaning its lifetime is tied to a specific request rather than the application lifecycle. You can learn more about these techniques in the injection scopes chapter. So I want us to learn Nest.js in a very straightforward way. And that is the reason why we are following the documentation and learning things the way things are supposed to be learned. So we also learn about providers. We talked about the technical details. That is the decorator scope, the token-based DI, factory providers, and value providers. So the decorators like the injectable marks a class as a provider. And then scopes, we have the default scope, which is a singleton. We have a request, that is per request instance, and we have the transient, that is a new instance each time. Those are the scopes. And it mentioned the scopes here. Providers typically have a lifetime scope that align with that is the default scopes. That is the singleton. And this one, they also have the request scope, which is per request instance. They also mentioned it here. However, it's also possible to make a provider request scoped. That is a per request instance, meaning its lifetime is tied to a specific request rather than the application's life cycle. It also have a transient, which is a new instance each time. Wow. Under providers, we also have token-based dependency injection. So can use strings, symbols, or classes as injection tokens. We have factory providers and value providers. And here we have custom providers. Next comes a built-in version of control container that manages the relationship between providers. This feature is the foundation of dependency injection, but it's actually much more powerful than we've covered so far. There are several ways to define a provider. You can use plain values, classes, and both asynchronous or synchronous factories. Wow, this is much. Great. So now that we've understood this, we also need to understand the injection mechanisms of a provider. So we have constructor injection, we have property injection, and we have custom tokens. So we don't even need to talk much. If you come over here, no, not here. So if you come over here, this is a property injection. If you hover over this, decorator that makes a class a provider. Providers can be injected into other classes via constructor parameters, blah, 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 blah. So this one here is a property injection. So using inject, oh, not this one. This one is injectable. There's another one known as inject, which is a property injection. This one is injectable, which makes constructor injection possible. So primary method using constructor parameters. Now, if you come over to the controller here, this is a constructor injection. We talked about constructor injection where we're learning about dependency injection. Great. So now that we've known what providers are, we can come back and review it. Providers are a core concept in Nest. Many of the basic Nest classes, such as services, repositories, blah, 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 helpers can be treated as providers. The key idea behind the provider is that it can be injected as a dependency, allowing object to form various relationships. So this here is a provider, and now it is injected as a dependency, and this forms dependency injection on high level. This controller here depends on the CAT service. Great. So now that we've seen what providers are, and the CAT service here is a provider. Great. Now let's move on. Moving on, we have modules. So a module is a class that is annotated with the @module decorator. This decorator provides metadata that Nest uses to organize and manage the application structure efficiently. So we have application module here. Under this application module, and if you come back to our code, we have application module, import controllers providers. Now, under this application module, we have the user module, others module, chat module, and this others module can have feature module 1, feature module 2, and feature module 3. So imagine that the others have cat module. So that cat module here, maybe another module. So this module will point to this, and this feature module 1 can have a sub feature module, which will be maybe 3 sub feature modules that will point to this, all will go up to the others module. So this is where architected, this is how we architected Nest.js is. So every Nest application has at least one module. That is a root module, which serves as a starting point for Nest to build the application graph. So this graph is an internal structure that Nest uses to resolve relationships and dependencies between modules and providers. So while small applications may only have a root module, this is generally not the case. Modules are highly recommended as an efficient way to organize your component. For most applications, you will likely have multiple modules, each encapsulating a closely related set of capabilities. So the @module decorator takes a single object with properties that describes the module. So as you can see here, let's go repeat this. @module decorator takes a single object with properties that describe the module, while the provider that would be instantiated by the Nest injector and that may be shared at least across the module. Controllers, the set of controllers defined in this module which have to be instantiated. And then we have the imports, the list of imported modules that export the providers which are required in this module. We have export, the subset of providers that are provided by this module and should be available in other modules which import this module. So you can use either the provider itself or use its token. That's the provided value. So the module encapsulates providers by default, meaning you can only inject providers that are either part of the current module or explicitly exported from other imported module. So the exported providers from a module essentially serve as a module's public interface or API. We have feature modules. In our example, the CAT controller and CAT service are closely related and serve the same application domain. So it makes sense to group them into a feature module. So a feature module organizes code that is relevant to a specific feature, helping to maintain clear boundaries and better organization. This is particularly important as the application or team grows. It aligns with the solid principle. Okay, let's open this up. This is another software development principle, solid. Solid is this word mnemonic for acronym for 5 design principles intended to make object-oriented design more understandable. So although solid principles apply to any object-oriented design, they can also form a core philosophy for methodology such as agile development or blah, 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 and so on. Single responsibility principle, open-closed principle, Liskov substitution principle, interface segregation principle, and all of those things. So this makes it solid. Dependency inversion principle. S, O, L, I, and D. So you can take a look at that if you wish to understand. Okay, so I just wanted to show you, highlight it for you so you can extend your research from there. So next, we create the CAT module to demonstrate how to group the controller and service. So we can use the Nest CLI to create this. In order to create a module with Nest CLI, we'll come over here and say, okay, first of all, clear the terminal. Say Nest G module cat. Now look at what happens in the cat directory. And now we have module. And we have the module with an argument decorator. This decorator with an argument of an empty object. So we can come over here. Now copy, we have controllers, providers. So essentially what we will do is, maybe let's come back. Export class cat module. And in here, controllers, which is an empty array, providers, which is also an empty array. Now Copilot is trying to help us out. We have the cat controller and cat service, which is a provider. Then if I hit, we have it in here. We can import it, and we have cat controller and a cat service. For now, the cat module is exported as an empty object. So now that we've created this, now we can go into the app module and then import the cat module so that it can be available in the root of our application. So if you come over to app module TS, we have imports, which is the cat module. So I don't know if you noticed something. Since we've been creating this, then we created the cat controller, we did not look at this file. We created the cat service, we did not look at this file. We created the cat module, we did not look at this file. But when we opened up this file, we can see that the imports here, we have cat module, we have cat controller, and we have providers, we have the cat service. Can you see that? So Nest.js is handling this for us. So when it sees that, okay, this thing you are creating, the app actually depends on this, it will automatically import it and then add it to the module. Now we don't even have to add it. It's already added for us. So let's look at what's next. Now, if you look at this cat module, so it is initially, because there was no module, we only had controllers and providers. We had to do this. We had to add controllers and providers so that it can be available in our app module. But now we have a separate module for cats, so we don't even need to bring in controllers and the cat service here. So we can do away with this. That's if we don't want to use the app controller and the app service. So we can remove this, remove this as well. And now we are good. We've imported a module here, which is cat module, and now it's available in our application. So if I go ahead and say npm run start dev, found 0 errors. Now, as you can see, cat controller, then we have cats, which maps to post, and we have the get as well. So now we are not posting, but we can quickly go ahead and then refresh. Now we can see an empty array because we've not yet added cats to our array. This is awesome. Remember what a module is. What is a module? Wow. The module encapsulates providers by default, meaning you can only inject providers that are either part of the current module or explicitly exported from other imported modules. So the exported provider from a module essentially serves as a module's public interface or API. Then we also looked at feature modules. In this case, the cat module is a feature module because we are dealing with cats. So everything about cats has to be in the cats module. This module, this blah, 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 export class cat module. So we have controllers, cat controller, cat service. And in here, we just import cat module and it's available in our entire application. So look at what happens if I come over here and comment this. Now, there's nothing like that. If I come over here and refresh, application breaks, cannot get cat because it's not available in the root module. We comment this out, save, and now it's available. If I refresh, we're good to go. Awesome. So at least now, here is how our directory structure looks now. We have the cat, and in the cat we have DTO, create cat DTO, yes. We have interfaces, cat interface TS, we have cat controller, cat module, and cat service. So we also have the app module and main TS. So now we have this because we don't even need, this was actually, when we scaffolded this application, we have this. We can delete this, we don't need it. We can delete the app controller. So let me focus, app controller, we don't need it. Nope, okay. App controller, we don't need it. The app service, we don't need the app service. But we need the app module because this is a root module. We need it for application to actually function. Great. Now look at, because in the root of the project here, we have app module, which is imported from this app module. And we say app equal to await next factory create app module. So if you remove this app module, you will have to bring in this cat module for this cat feature to work. But we need this because every other module created will be imported and added to this imports here so that it can be able to be, we can access it in the root of our project. That is great. So now we've achieved this structure. So we have to move on. So we also have shared modules. In Nest, modules are singletons by default, and thus you can share the same instance of any provider between multiple modules effortlessly. So we have user module, other module, cat module. This is a shared module. You can share it to this one, share it to this one, share it to this one. Great. And now the cat module, we can export the cat service. So every module is automatically a shared module. Once created, it can be reused by any module. Let's imagine that we want to share an instance of the cat service between several other modules. In order to do that, we first need to export the cat service provider by adding it to the modules exports array as shown below. So if we want to use the cat service in another module, first of all, we have to export it in our cat module. So we'll come over to our cat module. Let me say export cat service. And what's Copilot say? Exporting cat service if needed in other modules. Thank you, Copilot. And now if you have a user module or any other module, we can be able to import cat service and then use it in that module. That is awesome. Wow. Now, any module that imports the cat module has access to the cat service, and we share the same instance with all other modules that import it as well. The same instance, it will not create a different one. So if we directly register, if we were to directly register the cat service in every module that requires it, it would indeed work, but it will result in each module getting its own separate instance of the cat service, and that is not what we want. This can lead to increased memory usage since multiple instances of the same service are created, and it could also cause unexpected behavior such as memory leaks, such as state of inconsistency if the service maintains any internal state. So by encapsulating the cat service inside a module, such as the cat module, and exporting it, we ensure that the same instance of cat service is reused across all modules that import cat service. Wow. So we can re-export modules as well. So imagine the cat module, we import it in another module and we can re-export it so we can re-import this module and reuse it somewhere else. As seen above, modules can export their internal providers. In addition, they can re-export modules that they import, blah, 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 and so on. So we have dependency injection. So we're still under modules. Okay. And we're out of time. Wow. So any questions so far? We look at feature modules, shared modules. We have not looked at global modules or dynamic modules and module resolution, but that will be in our next class. So if you have any questions, you can go ahead and ask. But if you don't have any, this will be the end of our class for today. Any questions? Okay, so in absence of any questions, we can call it a day. So,